value. We open the winding parameters. And we say, the first tab that opens is the mandrel offset. This is what we need. So, there are two values. The positioning length, Y. This is where I put this value. The positioning length, Y-axis. So we say 250. Okay. Next thing, there is another parameter that we need to add here. It's called the minimal distance Z-axis, Z-axis. So that means when what is the clearest position from the mandrel to the eye rotation. We define what is the distance that we want to have. So now it's defined 35 millimeters, and this is some optimal value, 30 millimeters. Yes? Yeah, this is the middle of distance. Right. Okay. So now the mandrel will know where to start. We'll check right out. We enter the reference. We have entered the reference point. We have entered the starting position, which we call positioning length. This is how we call the starting point of the mandrel that we measure from the reference point. Okay? We call it positioning length. We enter it here. So now we click OK. So now we create a new helical layer. View. Okay. This is the new layer. It says that the starting point of the layer will be 155. This is what the expert thinks is the starting point for this mandrel, for helical layer. And for the Z is some 70 millimeters. Okay, let's save it. Let's save it. Helical. Yes, we're overwriting the old one. Okay. Now we're going to delete delete. Then we're going to save this. So now we're going to run this project. I'm going to show you how to run projects. Open the commander, file, open project, training, find the file. This is the MNC file. Okay, project loaded. Go to auto, mode, auto. Start. There are people. We cannot stop.
You want to start? I will get start. Oh, where?
Oh, I think you're safe there. Give it минутку понавал. Стой, минутку понавал, we can keep. No. Okay. I think it's at safe distance. So now, you see, the find path button is blinking. Either press this one or this one is the same.
Yeah, it's find the starting.
Because we said find path button, yes.
Always,
so now
yes.
It's waiting for us to click the find path button. Pazi, Dime. Baš stavke odom, čekaj.
Ajde, tjeraj ga. Ама не, просто ова се пише на камера.
Okay. Now, come closer, please. By entering the right reference point and entering the right positioning length, the expert knows where the starting point is for this helical segment, for this typical specific mandrel. If you can see, we measure it, it's 35 millimeters of minimal distance, and it is right at the beginning of the mandrel. For a length of, I don't know, for a bandwidth of bandwidth of 15 millimeters. So the center of this eye should be about 7.5 millimeters from the edge. You find this hard to understand. Positioning of the mandrel, finding the starting point, the reference point, is slightly difficult maybe, because you only set the reference point once, never again. This is the reference point, you don't need to change it. It's been set, it's set forever.
Only the mandrel we need to.
Yes, if you change the mandrel, then you measure like this. Oh, it's here. I'll enter it in the positioning length, and the expert knows where the starting point is again. Okay? So I'm teaching you how to set the reference point and how to measure the positioning length. But the reference point you never need to use, except if you want to change. I say, not this, I want to use this. This is my new reference point. Then you need to measure it again and enter it in the expert. But I don't think so, because this is very good reference point. It's starting. So next time you measure a mandrel, you measure from here to there. Let me show you a different type of mandrel. Let's create a vessel type of mandrel. Vessel is also known as reservoir, a CNC. We call it a vessel. This is how it looks like. When you place a vessel mandrel on your machine and you want to measure the positioning length, you measure it up to this point where the cylindrical part starts. Okay? We always need the cylindrical part of a vessel. We don't measure it to here, say positioning length is from here to here, no, from here to there. We are interested about the cylindrical part. Okay. So let's say this vessel with the default values. Say this is a vessel. Okay. So you have a project with a vessel mandrel. Basically everything is the same as working with a tube mandrel. You have a radial segment, helical segment. Wow. Additionally, you have transitional segment. This is a specific segment only for the vessel type. So what is a transitional segment? Transitional segment is a segment that connects radial and helical. It connects them. So when you make one helical radial layer from here to here, you want to continue making helical layer. If you just start with here, it will break, the fiber will slip. Because it goes from 90, let's say, to 5 degrees. And it will pull the fiber. And you have broken the radial layer. So now you need to adjust the angle first in the position. You do a transitional segment. The transitional segment will slightly decrease the angle, let's say from 90, 80, 60, 70, 40, 30, 10, 5 degrees. So it will transition the angle from a radial to the desired angle for the helical layer. And vice versa, it will increase an angle when you have finished with the helical layer and you want to continue with a radial layer. So then it will increase the angle from 5 to 90. Many other softwares, they do this by hand. They calculate transitional layers by hand, but we use it with our software. So let's see how helical layer looks like on a vessel type of mandrel. So here we set the fiber speed, the bandwidth, the angle, the direction, positive, negative is all the same. But now we have something different. We come to this information called the left and right opening diameter. Okay, we change the view. This is opening diameter. So the vessel type of mattress, they have openings each side. The opening on the left side is this. It's used to connect the mandrel to the machine. On the right side, they also have very small openings. It's used for symmetry and balance and for support. There, that little part can be connected to this unit here, so that it can be secured that the mandrel will always rotate in one axis of symmetry. Instead, it will go like this if it's not connected to the tailstone. So now, we enter the values for the opening diameters, 25, 25, and this is the important part. There is angle on the left and on the right side. If you have different openings, let's say 25 for the right, 50 for the left, the expert gives you different angles for each side. That's because the one angle, the angle that's calculated for each side is the ideal angle for that side. But in this case we have two angles and we don't want that. We want only one angle. So we choose the angle we prefer the most. Let's say we want 5 angle and we apply to the both sides. Let's say an angle of 8 degrees. This angle is demanded by some project. Some buyer says, I want you to make me, let's say, 1,000 reservoirs with angle of 5 degrees. That's usually asked for by the buyer. So you enter the angle here and you calculate the segment part just like you did with the tube mandrel. Maybe a little bit slower. This is more complex. Okay, there it is. We choose a pattern. The simulation, okay, here's how it goes. Okay, let's look at the simulation mode. This is how I can explain the patterns with this type of vessel. I'll start from the beginning. Let's play the simulation of a 5. I will not call this lash, I'll call it dot, 5.1 pattern. So, we have two numbers, 5, the first, the second is 1. So what does it mean? One cycle. This is the fiber here. Remember it because it is the first position of the fiber. Cycle 2, cycle 3, cycle 4, cycle 5. 5 cycles get passed. And this is our original fiber position. Now, after the 5 cycles, the next one is right to the first. So it says, after 5 cycles, the next fiber will be 0.1, so one position to the first, next to the first. If it's 5.2, it will be one empty space and fiber. If it's 5.3, 2 empty spaces and fiber. This, do you understand it? Yes? Okay. Nobody understands this at first. You're the first one.
Negative is starting from
yes, left or right, left or right.
So
That's the negative.
Negative is which side?
it depends on which side the fiber is going. It's going like this, negative is on the other side. The fiber is going to the right, negative is from the left side. So let's see here. The fiber is going to the left, so it's from the right side. That's negative. Patterns 3, 4, 5, 6, 7 are excellent patterns for vessel. They're most demanded for. So now I want to demonstrate how you do transitional layer. You choose transitional here, and the parameters bandwidth, fiber speed, direction. So next thing what you do is you have to define where you are and where you want to be. So you say, I'm at the diameter of 100 now, and this is not set, I want to be at the diameter of 100. No, that's not true. Because we said, you see, this is the diameter. Here is 0, here is 150. Okay? See. Here it's 0 diameter. Okay? Here is 150. Let's say here is 10, 20, 50, 100, right? At each of these diameters, there's a specified angle. So, you have to connect the existing angle of the helical. We used 8 degrees, I think, right? So, this is 37. I have to adjust the diameter to the angle. So you lower the diameter until this becomes 8. Now we lower. I think that 20 will be good. 7, okay, 21 maybe. 25. Okay, a little bit more. Okay, this is it, 8.7. I think that was the angle, 8.7. So 25. I say, start from angle of 8.7, that's here somewhere. And continue to now I'll go to the maximum diameter. I think it was 150. No, it wasn't. It was more. 164. Okay, 89. 89 is the angle of the radial layer. It's close to 90. So now you're saying connect my helical layer to my radial layer. This is what you're saying. Go from 8 to 90 degrees. Make me a layer that will connect my two layers. So now you calculate this. Okay, simulation. This is it. That's it. It started from here, from angle of 8 degrees. It goes to here. As you can see, the angle increases all the way. Right? So here, it's probably some 35 degrees already. So it goes here, here, and it finishes up to here. And here it's 90 degrees. It's ready to start a radial one because it's already 89 degrees. It's a connected layer
between radial and helical.
Yes, radial and helical radial. If you want to connect radial with helical, you just switch those. Making diameters, angles, and you get the other connecting layer. Pause.
Each transition is a segment by itself.
This what?
The transition is a segment by itself.
Sorry, it's
Is it one segment?
yes, yes. So because this is a segment, we calculate it, now is view, save, add, everything. It's a segment. Now we add transition, trans, enter, okay, close this, now it's segment. You play it like, you run it like a segment.
So you play the helical one first, then transition, then the radial.
So yes, yes. The order that you need. You have first radial, then helical, then you need radial, transition, helical. This is for vessel, not for tube.
radio, how to use
I think we can stop now.
Yeah. Is it necessary to have radio or not?
No, we're going to
It is necessary to have one. Somebody is making those projects, measuring some demands and everything, and they tell you make that.
Yeah.
You don't know that.
Don't know what.
Just you do what somebody tells you.
They say they want helical and radio unit.
I think we can make a small break.
Yeah. Maybe.